Good day, students. Welcome to part 2 of the Algebra 2 Trig Regents series for January 2013. On this installment, I'm going to be going over questions 6 to 10. All right, let's start out by taking a look at question number 6. It says, which expression is equivalent to quantity 9x squared y to the 6 raised to the negative 1/2 power? Okay, so this is a question on laws of exponents. So let's see. We have 9x squared y to the 6th all raised to the negative 1/2. All right, so first thing I'm going to use is the reciprocal property of exponents. If you have a negative exponent, that basically means that you need to reciprocate the quantity that has a negative exponent attached to it. All right, so we're going to reciprocate this whole expression, and that will change the sign of this exponent. So we're going to have 1 over a quantity 9x squared y to the 6th raised to the 1/2 power. Okay? Now what we're going to do, in order to simplify the exponents with ease, we are going to express every single term here as exponents, okay? The x and the y is already expressed as exponents. How about 9? Can we express 9 as an exponent? Well, let's see. What we're going to do is basically break it down using the factor tree, okay? So 3 goes into 9 three times. So we can express 9 as 3 to the 2nd power, all right? So we're going to write this as 1 over 3 square x to the 2nd y to the 6th raised to the 1/2. Okay? Now it's going to be easier for us to use the power of a product of powers property of exponents to simplify. So what that property tells us is that if you have a power of a product of powers, you just simply multiply the power on the outside to the powers of the product of powers, right? So this 1/2 will be multiplied by the 2, it will be multiplied by this 2, and also it will be multiplied by this 6 right here. So if we carry out the multiplication, what we'll have is 1 over 3 to the 2 over 2, x to the 2 over 2, and y to the 6 over 2. All right? Now let's simplify that further. We're going to have 2 over 2 is 1, so we just left with 3. 2 over 2 is 1 also, we just left with x. And then 6 over 2 is 3, y to the 3rd. Now, anytime you have 1 as an exponent, you don't need to put it there, okay? So you just write it like 3x and then y to the 3rd. All right, so there goes your final answer. So our answer is option number, let's see, number 1. All right, so there goes our final answer right there. Okay, moving along. All right, let's take a look at question number 7. It says, in a certain high school, a survey revealed the meal amount of bottled water consumed by students each day was 153 bottles, with a standard deviation of 22 bottles. Assuming the survey represented a normal distribution, what is the range of the number of bottled waters that approximately 68.2% of students drink? Okay, so basically to make use of the normal curve in the standard deviation, you can refer to your reference sheet and you have this graph right here. Okay? Okay, so the center is always the mean. All right, so this is the mean right here, mu, and each calibration is a deviation from the mean. So 0.5 is basically 0.5 deviation from the mean, and then this is one standard deviation from the mean, and it goes on and on like that. All right. So we're looking for the deviation that captures 62%. I'm sorry, 68.2% of the entire sample space. So let's see. If we deviate 0.5% to the left and the right, how much population do we capture? Okay, what is the range that's captured here in this region? If we go 0.5, remember the target is 68.2. So if we go 19.1 to the left and 19.1 to the right, it's basically 2 times 19.1, which is 38.2%. So if we deviate a half of a standard deviation in both directions, we're going to hit 38.2%, but that's not what we want. What we want is 68.2. So how about we go one standard deviation to the left and one standard deviation to the right? So, so we're going to make it a little bit bigger. We're going to look at this whole region right here, this entire region. So since we've already added a half of a standard deviation, what I'm going to do now is I'm going to add this 15 and this 15. Okay, let me make it easy for you to see. So we're looking for this entire region, one standard deviation. So, so 15 and 15 is 30. If we add 30 to what we already had before, what do we get? Add 30, we get 68.2%. So you see, if you deviate one full standard deviation to the left and to the right, this entire region will be, from here to here, will be 68.2%. Okay? So whenever you're trying to calculate the percentage, you have to go equal measures in both directions. And all you just do is basically add the percentage. So if I add this, this, that, and that, add them all together, I'm going to get 68.2%. Okay? All right, so how can we represent that using a range, a numerical range? So in order to calculate that, we're just simply going to make use of our mean and our deviation from the mean. Okay? So the mean is the center point. This is mu right here. Let me use a straight ruler. So this central value right here is the mean, denoted by mu. Okay, and then we're going to be deviating one standard deviation to the left and one standard deviation to the right. Okay, so one full standard deviation to the left and one full standard deviation to the right, so that we capture that 68.2%. Okay. All right. So it's basically 34.1% in both sides. All right. So what on earth is that expression going to be? This is this line and this line right here. This piece is going to be mu, the mean, minus one standard deviation, and then this one right here is going to be the mean mu plus one standard deviation. All right. This is just a standard notation. So what do all these symbols mean? Well, basically, the standard deviation mu is 153. Okay? So the lower bound of our range, lower bound, is simply 153 minus one standard deviation. What is one standard deviation? We're told that, let me indicate it here. Mu is 22. Okay? So the lower bound is 153 minus 22. 153 minus 22 is 131. 131 if you do the arithmetic. And the upper bound of our range is going to be the mean plus one standard deviation, okay? Plus 22. And then if you add it up, you get 175. Okay, so our range is going to be from the lower bound to the upper bound, which is from 131 to 175. And there goes our range. So our answer is option number 2. Okay, so there you have it. All right, let's take a look at question number 8. It says, find what is the fourth term in the binomial expansion. So for that one, we're just going to be using a piece of the binomial theorem. Okay, the binomial theorem, if you want to sum x plus, well, let me use a formula on your reference sheet. Okay, it uses a and b. All right, so a plus b to the r. Let's use that notation for the sake of consistency. A plus b to the n is given by the sum from, let's see, r equals 0, from r equals 0 to n of and choose R, a to the n minus R, b to the R. Okay? Alright, so this is your binomial theorem, expansion of a binomial using the binomial theorem, expansion of binomials using the binomial theorem. Now, when you're looking for just one term, all you focus on is this piece of the binomial theorem. Forget about the sigma. Sigma adds up all the individual terms, but we're looking for one term. We want to generate the fourth term, okay? So for any term, the n is always equal to the power. That never changes, right? The thing that changes is r. So for the fourth term, n equals to the power, which is 8, okay? A is x, b is -2. Please, please, please take the sign along with you, alright? If you don't take the sign, you're going to mess the sign up. If you notice that signs are different in the options here. So you notice that this is negative, so b is also going to be negative. Now another part you have to be extremely careful about is r. Since most people would think that r is 4, since we're looking for the fourth term. That's absolutely wrong. Note that we're starting from 0. So you start counting from 0. 0 is the r equals 0 is the first term. The second term is r equals 1. Third term is r equals 2. Fourth term is r equals 3. So r is always 1 less than the term that you're looking for. So you're looking for the fourth term, r is going to be 3. Alright, so this is a big mistake that most people make. So please be careful with your r and also with the sign of b. Okay, now we'll just simply plug all these values into this component of our binomial theorem, and that will generate our fourth term for us, okay? Alright, so let's do it. So we're going to have 8, choose 3, x to the n minus r, 8 minus 3, and then b is -2 times -2 to the r, which is also 3. Okay? Alright, now let's simplify that. We can use our calculator to compute what this combination value is. 8 choose 3. Let me show that to you real quick. Alright, so there goes my calculator. I'm going to calculate 8C3. Let's see. So you can go to catalog in your calculator, and then go to n, and see NCR right here. That's the function for calculating combination. Okay, so NCR, you select that. Oh snap, sorry. You're gonna enter the first number first, 8, and then you go catalog, and then N, CR, and then the second number 3, and then enter 56. Okay, so that goes the number of ways you can choose 3 elements from 8 when order is not important. So you're gonna have 56 combinations, x to the 5th, -2 to the 3rd is -8. Be careful, if you're raising a negative number to an odd power, the negativity remains, okay? Okay, so now just multiply 8 times 56. That's basically 400 plus 48, which is 448. So multiply these two, you get 448, -448, x to the 5th. Okay, and there goes your the fourth term on the expansion of this binomial right here. So our answer is clearly option number 3. All right, let's move on to number 9. Number 9 is another question on exponents. So we have 8 raised to the power of 3k plus 4 equals 4 raised to the 2k minus 1. So to solve this, we need to get, if I can get these bases identical, then I can basically cancel them out, right? Using the logarithms to cancel them out. But the bases are different, so how can I make them the same? Well, if you notice, these two are powers of the same number, right? This is the third power of 2. This is the second power of 2. So I can express this as 2 to the second power, 2 to the third power, times the existing exponent, which is 3k plus 4, equals, and then instead of 4, I express 4 as 2 to to the second power times the existing exponent, which is 2k plus 1. I mean minus 1. Okay? Now, note when you're simplifying this exponent, this 3 must be distributed to these two quantities, these two terms in this quantity, and then these two has to be distributed to these two terms in the quantity right here, okay? So we are now going to have 2 to the 9k plus 12 equals 2 to the 4k minus 2. Okay, now to you notice that the bases are the same. So if the bases are the same, it follows that the exponents are also the same. So we can just cancel out the bases and we have 9k plus 12 equals 4k minus 2. Alright, because we have equivalent bases, we can just cancel the bases out and then say the powers equal to each other. Alright, so if we can isolate k, then we'll be done. So to do that, I'm going to subtract 4k from both sides. And then I'm going to minus 12 from both sides also. So we're going to have 9k minus 4k is 5k equals, these add up to 0. 4k minus 4k adds to 0, and this is negative 14. And then divide both sides by 5. And your final answer k is negative 14 over 5. So our answer is option number 4. Alright, so that's that. Now let's shift our attention to question 10. It says, there are 8 people in the tennis club. Which expression can be used to find a number of different ways they can place first, second, and third in the tournament? So the question is it a combination or permutation? We're selecting 3 people. Now remember the word permutation. Permutation, what letter does it start with? It starts with a P, and you can think of this P as placement. Okay, placement, or you can also think of P as in position. Okay, what do all these indicate? Okay, I can't even spell. Position. What do all this indicate? This indicates ordering, some kind of ordering. Okay, so when you have permutation, order is important. So let's take a look at this question. Are we ordering elements of a set? Absolutely. We are ordering, see the word place here? And then first, second, and third are ordinal terms. We're ordering 3 elements of a set. So this is clearly a permutation question. So we can drop 4 and 2. So since we're ordering 3 elements out of 8, the answer is going to be 8 place 3. Okay? So how they the question says, how many ways can you choose 3 players? If they said choose, then you know it's combination. Okay, so don't forget combination involves choice, or you choose, and then that has to do with there's no order. Okay, if you select 1 2 3 3 2 1, it doesn't matter how you order them, they're all the same, counts as the same. Okay, so in this case order is important, so we have permutation, and we're placing 3 elements, so this goes your final answer, 8p3. So we can clearly see that our answer is option number 1. Okay, so there you have it. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking here so you can get updates to the next installments to this review series. Please post a comment to let me know what you think about this presentation. And you can also click like if you like this clip. Thanks again, and have a wonderful day.